Four students A, B, C, D are having a chess tournament. Even though this isn't much of a sport, but it's a tournament, so you get the idea. There has to be one match between every two students. What does that mean? It means that this is a round robin. For every match, the winner gets 2 points, the loser gets 0 points, and if there is a tie, then each player gains 1 point. It is known that students A, B, C, and D. Okay, so it is known that students A, B, C each have 3, 4, and 4 points after the tournament has ended. Student C has never tied before. Student A has won matches, and student B has tied before. So, how many points does student D have? I'm not really sure where to start right now. So all I'm going to do is write down the 4 names A, B, C, D. Now, how much points does A have? A has 3 points, B has 4 points, and C has 4. I'm trying to find how much D has. I'll leave D blank for now. But I wanna kind of look at how they got their points. So how much they lost. So the combinations of points. Because over here it gives us a good clue. Student C has never tied before, which means that student C cannot have ones in it. Student A has won matches before. It means that student A has at least 1, 2 in there. And student B has tied before. So student B has at least 1 point in the 4. So let's write that down. So student C has never tied before, so student C cannot have ones. Student A has won matches before, which means that it has at least 1, 2, because each winner gets 2 points. Student B has tied before, means that it has at least tied once before. But this doesn't really make sense right now. 3 equals 2, 4 equals 1, what the heck? So what I'm going to do is figure out how much games each person plays. After I know how much games each person plays, then I can easily figure out each combination. So do you still remember how to find that? From our very first video, when we started introducing the concepts and equations to you guys, we talked about how for round robins, each team has to play n minus 1 rounds, n being the number of teams there are. In this case, we have 4 students, which means we technically have 4 teams. So we had 4 minus 1, and that equals 3, which means that each team plays 3 games. Now that we know that, I'm going to just add 3 blanks to each equation right here. Shows that there are 3 numbers waiting to be filled up. Now let's do A. 3 is equal to 2 plus something plus something. Now, when the point system is 2, 1, and zeros, I would like to call that the 2-1-0 system, which means that the winner gets 2 points, ties each person gets 1 point, and if you lose, you get 0 points. Great. So if we want to fill in these 2 blanks with a combination of 2's, 1's, and zeros, and equal that to 3, what would that be? Well, if you test it out, really, there's only one option. That's 2 plus 1 plus 0. Any other combination would be wrong. Okay, now number 4. 1 plus something plus something. After testing every single thing out, you will see it's 1 plus 2 plus 1. That would be the only thing that works. Now for 4. What I want to tell you is you might think there is no way of actually solving this because we weren't given any clue. Or were we? It said that student C has never tied before, which means that it cannot have the number 1s in it. So if we can have 1s in this combination, the only possible answer to this is 2 plus 2 plus 0. So we have A, B, C filled up, but really, what are we trying to find in this problem? We're trying to find how much points does student D have. And so far, we haven't even thought about that yet. So how do we use the information from here to there? So this is when some just common sense comes in. Whenever you have a match, right? It's either there's a winner and a loser, or there's two people who have tied, which means that the number of that means that the number of points of tying points has to be even, because whenever there is a game that ties, two teams have tied, right? Two teams have tied. And in games where there's a winner and a loser, there's one winner for every loser. So that also tells us that the amount of winners and losers are the same. So let's start from there. How many winners do we have? How many winning games? We have 1, 2, 3, 4. 1, 2, 3, 4. And how many losing games do we have? 1, 2. So we need 2 more zeros here. And we could just put them right here with D. Now all we have to do is fill in this one. Now we're going to go over to our ties. So a tie, the number of ties has to be an even number. Right now we have 1, 2, 3 ties. So in order for it to become another even one, all we have to do is add another 1 right here. So 0 plus 1 equals 1, which means that how many points does student D have? Student D has only 1. Now, there is a method 2 for this problem. So this method 2 is especially for problems that include the system 2, 1, 0. Because if you think about it, every 2 matches with a 0. And every 1 matches with another 1, right? Because for every winner, there's a loser. And for every person who tied, there's another person who tied as well. And that is something we covered in the last method. But we can actually just expand on that. So no matter what different types of combinations we have for each person, what value never ever changes in this entire problem? That's right, the total points never change. So no matter how much combinations you have, the total number of points after you add all of those people's points together never change. So we can expand from that. First, for how many matches, okay, so each match actually results in a total of 2 points. For matches that have a winner and a loser, they add those two values up, you have 2 points. For matches that tie, you add 1 to 1, that gives you 2 points as well. So every single match in here has 2 points. And we're trying to find the total amount of points. So all we have to do is find how many matches there are. So do you still remember how to find that for round robins? So that would be n times n minus 1 divided by 2. N being the amount of teams there are. In this problem, there are 4 kids competing against one another. So that would be 4 times 4 minus 1. And then divided by 2. Using the associative property, we can first do 4 divided by 2, that's 2. Times, what's 4 minus 1? That's 3, right? So that's 6. So they need 6 matches in total. Each match is 2 points. So that would be 6 times 2, which equals 12. So the total number of points would be 12 points. And how do we find the number of points that student D has? Remember, we already have the number of points that students A, B, and C have. And that would be minus 3, minus 4, minus 4. And that's just easy, just subtraction. So that would be 12 minus 3, 9, 9 minus 4, 5, 5 minus 4, 1. So we only have 1 point for D, and that's also our final answer. Notice how for this problem, we didn't have to go from the beginning. If we just actually slowed down to observe a little more, this problem actually isn't that hard. It's actually less complicated than the first one. So the next time you meet not just round robin problems, but any problems that include 2, 1, 0 point system, you can always use this type. Just find the total amount of points for each game, find the total amount of games, multiply them, minus all the other points, and you find your answer. So thank you for watching this video, and see you for problem 4.